Ooh, the last 18 months. Purge, prime, and wipe. Scan the van.
Welcome back to 3D Printing Today, the podcast about all aspects of 3D printing. Hobby, professional, industrial, it doesn't matter, we cover it all. My name's Andy Cohen, and I'm here with Mr. Whitney Potter. Hey, Whitney.
How you doing, Andy?
I'm doing pretty good. We do have an interesting story in the news this week about how a bunch of researchers at USC and at the Swiss Federal Institute of Technology have worked together to come up with a way of saving the waste of breakaway support material. I just thought this was really interesting. Did you see this article, Whitney?
I did, yeah. It's super cool. In addition to saving waste, you're also saving potentially a lot of time. So basically what they did is instead of having a perfectly flat, uniform, one-piece build plate, they turned the build plate, sort of chopped it up into a grid of squares, and each one of these squares is on like a little piston, so that as you're printing, when you need support, instead of building support from the base, from the build plate up, you can raise however many of these little sections of the build plate you need, and then you can start building support, raise it as close as you can, and then start building support from there. So you're dramatically reducing the amount of support material you need to build. So it's a pretty slick system. What I thought was super cool about it is if you watch the video, and the video is the only place you can actually see the real machine. I kind of hate it when they do that, when they just show renderings in the article, and you're like, so did they actually do this? But you read the watch the video, and you can see they actually built a machine to do this.
Very
what's
cool.
super cool about it, they built it on a CME CNC Orion. If you think about it, you're probably best off doing this sort of thing on a Delta type printer because the bed doesn't move on a Delta, so it makes it a whole lot easier to build all of this extra stuff onto it. But yeah, very cool system. The only reservation I have is that you're adding so much complexity to your printer. You think about all the moving parts you have on your printer already, and now you're adding, an order of magnitude more moving parts, and they've all got to move perfectly for it to work.
Yeah.
So that's a little bit of a problem.
I know, but
yeah,
I couldn't help but see this technique and think, well, what if the bed was made of a flexible, stretchable material, and underneath you had a higher resolution bed of nails that matched the shape of the bottom of your object, and then you'd have 100% dense support on the bottom of your object while you're building up, and that's reusable. That would be cool. Now, the question is how the heck do you do that? Imagine you'd have to use something like a very flexible polymer to get that shape. That would be way kind of complex, way beyond today's technologies, I'm afraid. Still, it's an interesting idea. I really got a kick out of it.
Yeah, and the stuff that they're showing, if you could commercialize that in some meaningful way, that could be very useful. Because the support's got two problems. Well, three problems basically with support, right? One is that you're wasting a lot of material. Two is you're wasting a lot of time, and three is if the support fails, the print fails. And a lot of support tends to be sort of tall and spindly, and if the tall and spindly stuff gets knocked over really easily, and then the print fails. So this could potentially solve all three of those problems. But on the other hand,
pretty expensive.
It has to be more reliable than printing support.
It'd be
cool stuff.
Pretty complex and pretty expensive. In the meantime, let's see what's coming up on our show this week, Whitney.
We start out talking about the last 18 months.
And then we talk about the need to purge, prime, and wipe for multi-materials.
And finally, I scan the van.
Let's do this. I got an email from an old friend of ours, GP Villemi. Remember GP?
Yeah, sure, I remember GP.
Yeah, he used to work at Autodesk, and he gave us a tour of the facilities down.
Yeah, he was one
pier.
of their 3D printing gurus.
Yeah. GP had the a fortune of being able to work with the earliest of folks involved with hobby 3D printing in the U.S., the folks that eventually became MakerBot. He was a member of the Makerspace that was the same Makerspace as those who eventually became MakerBot and SolidDoodle. So he's from that group, and his perspective was fairly interesting to hear quite a bit when he's been on the podcast quite a bit in our old shows, and we've spoken to him quite a bit. And unfortunately for GP, he made the mistake of buying the Replicator 2X. Now, I understand that because I almost made that mistake too. I bought my Rep 2, and then the Replicator 2X came out, and I thought, oh, I want the better one. Well, I got the better one. The 2X, in my opinion, the 2X was a failed 3D printer. I know GP's been able to get it to print really nicely, but like the Rep 2, it needed an enormous amount of work and replacement. It was not engineered correctly, in my opinion. Not a good machine. If somebody's offering you a Replicator 2X, probably not worth the space it's going to take up. Probably not worth it. And of course, his email to me was, hey, I've got a couple of machines I want to get rid of, including his Replicator 2Xs. And we continued to chat about it. And he came back with an email that was kind of like, hey, I found out that a friend of mine bought a CR10, a guy who knew nothing about 3D printing, took it out of the box, put it all together, and was printing at higher quality than anybody could have gotten with the Rep 2X. And that was enough for him to say, I'm done. Get rid of it all. And I then kind of went back and thought, wow, you haven't been around. It's been pretty exciting the past 18 months in the hobby 3D printing world. And if you were involved with MakerBot and dropped out of that world, of which a substantial number of my old acquaintances from the old MOG forum have done, a lot of them have bailed and walked away. A lot has changed, and you're missing out because the last 18 months and probably the next 18 months have been really exciting. A lot of things have happened, including, well, the CR10 and Ender 3 have basically taken the entire hobby market by storm. Prusa has become the artisanal, high-quality Mendel machine. It wasn't 18 months ago, and it became that when it's upgraded. Its last bunch of upgrades that moved to aluminum extrusions have turned it into the Cadillac of Mendel's, as well as the Prusa slicer. So there have been quite a bit, the MMU2, quite a bit of advances coming out of Prusa Labs that have pushed the rest of the marketplace forward. The MMU2 has pushed our friend Bill Steele into the 3D Chameleon. He's now in his second version that we're waiting so that we can start installing it and using it. So, the whole world of multi-materials has really taken off. Now, the palette the palette's still out there and it's still advancing, but it's been leapfrogged by the 3D Chameleon. And then there's E3D's Tool Changer, which we got it about 18 months ago, and it's probably the most reliable approach to multi-materials out there right now. I love my Tool Changer. I go up to my Tool Changer. My Tool Changer sits right next to the Race 3D N2, by the way. So the two very, very powerful, very reliable machines. And there's other stuff happening. There's tons of hot ends that are appearing on the marketplace now. Tons of extruder driving systems that are on the marketplace right now. We are so much better. We've got the smoothie board. We got the duet boards. You know what's lagging right now? The one thing in our marketplace that's lagging, slicer software. While Idea Maker is becoming its own renowned slicer, and Cura is still in there and continues to be upgraded, unfortunately, Simplify 3D has completely dropped the ball, and we have not seen a major upgrade in years. Unfortunately, they have cash cowed that software. No upgrades, no changes, no updates. So that's kind of fallen between the cracks. I would say that of all of the elements out there of the 3D printing world, the software has not kept up with the hardware at this point. Materials, we've been seeing advances in materials. We've got NGen, which GP was very familiar with, by the way. He printed a lot with NGen. We've got better formulations of PETG right now. Right now, the predominant materials, still PLA for hobby machines and PETG. I'm getting formulations of PETG that are way superior to what we used to get. ABS is falling by the wayside. I'm getting higher quality nylons than we ever had before. And then we're getting the silks, the metallic silks. We're getting combinations of materials such as the matte fibers from our friends up north of here at Protopasta. I mean, there have been advances in the past 18 months to 2 years that way surpass what we were imagining 7-8 years ago when the replicators came out. You know, if for those of you out there you're listening and you have not been involved, you're missing it. It's been pretty exciting the past 18 months.
Yeah, not only are these so many more options now that we didn't used to have, but they've also become so much less expensive.
Oh, yeah.
I mean, the printers are so much cheaper and more reliable. The filaments are cheaper and more reliable. And when was the last time you bought bad filament? And it used to be if you bought bargain filament, you were taking the chance that you were going to get, little bits of metal shavings and stuff in the plastic melt that were going to clog up your nozzle, and your nozzle was going to, you were going to have to wait, a long time to get a new nozzle to get your printer running again. Now you can get, nozzles, delivered overnight from Amazon for 50 cents each, and you can buy very reliable filament that doesn't go out of tolerance and doesn't have foreign matter in it and all kinds of stuff for $15-20 a kilo, and you can get that delivered next day too. So yeah, things have really smoothed out. The technology hasn't changed that much. The fundamental technology is still what we were using back then, but it works much better now.
I can tell you one thing's for sure. Now is not, after Christmas is the worst time to buy filament. It's all gone because everybody got a 3D printer and they're all buying filament. So good luck finding good filament at a good price. It's in January. It's not the month to look for filament. And then after January, you have the Chinese holidays. So the Chinese producers are not putting stuff out. So usually winter, buy your filament in the fall. That's the time to buy your filament.
I've got so much filament sitting around that if I'm not particular about color, I could print for years.
So now that multi-materials 3D printing is becoming more prevalent out there are a couple of things that are kind of important to understand, because these three functions are probably going to be important for any style of multi-material, whether it's the palette, dual extruders, the 3D Chameleon, the MMU, the Multi-Materials Unit 2 from Prusa, or the tool changer. All these 5 different methodologies are going to need to do this in some way, shape, or form, and that's purge, prime, and wipe. Now, with palette, the palette has these purge blocks, and the design of the slicing for the palette works with all 3 of these, with these purge blocks, because the purge blocks do all 3. But let's talk about what each of these functions are. Purge is when you've got a different material still in the process that you need to get out. So like with the palette or with the MMU, you may still have stuff in the hot end that's a different color, and you need to get it out of there. Prime is where you need to get everything all set up. In fact, we do a prime for almost all of our 3D prints. It's either the skirt or a priming line. And the purpose of that is to get the right amount of material, get all of your material all throughout the hot end, through the thermal tube into your nozzle and out of your nozzle, and get it so that it's perfect to start printing right away. And that's different from wiping. Wiping is when you may have stuff dangling or smeared on the side, and you need to make sure that everything's clean before you start actually extruding and printing.
Well, quite frequently in the process of priming, you end up with, particularly if you're doing a freeform prime where you're not extruding onto a prime block, but you're just extruding in space. It's not unusual for that filament to curl back around and stick to the nozzle. So you got to have something to do to wipe that off, because you don't want to be dragging that around through your print.
Right. Now, like I was saying before, the palette does this purge block that's pretty significant, and it will do the purge and make sure that the transition is overcome so you're in the right color, and it primes it and it wipes it. Well, it hopefully will wipe it. There's nearly no wiping between the prime block and actually printing the object. Now, if you've got an IDEX machine, most IDEX machines do not take these into account, so you have to either do it within your slicer as a purge block or a prime tower, or you'll need to add some hardware, which I would recommend that over doing it with your slicer. And eventually we'll get an IDEX in here, and I will make up on the gantry, because remember, in most IDEX machines, the bed goes, the gantry to the x-axis is at the same level as the hot end. So that's where your purge area and your wiping facility has to be. With the tool changer, I can put a purge area separate from a wipe, separate from priming. I could do all separately, and that's what I do. I purge off to the side, and I wipe each time with a bungee cord. It wipes the nozzle, sweeps past the bungee cord, which knocks off anything. And then I go to the silicone wipe that we came up with, and I get a nice clean surface, and I'm all primed up, and I go print. That's been the most reliable approach. It also uses a fraction of the filament that the purge block and the prime tower would use. But those are the three functions you have to take into account. Just buying an IDEX 3D printer is not necessarily going to give you those three functions. You then have to figure that out. Hopefully you're buying a 3D printer with enough of a community where other people have come up with solutions for you that you could just grab and use. But purging, priming, and wiping is something you still have to do.
I would say do whatever you need to do to avoid having to have a purge block or tower or something. Whatever you need to add to your printer, because the purge block. I remember when you were working with the palette, the filament switcher welder methodology. And I looked at some of the prints you made, and literally the purge blocks were larger than the object that you printed if you were switching colors very frequently. And that's just wrong. That's just, it's a non-starter. Yeah. It 3D printing won't work if that is a requirement for multicolor. So we've got to come up with a better solution. The palette where you're all doing it through one nozzle, you kind of got to do that. Either that or bury your transitions in the infill, which would be a more clever approach, but it's difficult to do that with the palette where you don't really ever know absolutely where that filament change took place. So you have to have a massive block to just make sure you're into the next color for sure. So with an IDEX or a tool changer or anything like that, you do not want to be putting in purge blocks, because that defeating the purpose.
Yeah, and let me add another negative to the purge block. We tried a purge block on the tool changer, and a purge block literally is for beyond the palette. The palette, that's not the case. Purge block can be a big block, but it could be an empty shell. But a purge block through your slicer or a prime tower through your slicer creates a 100% infill object. And that could be a problem, because when you get to 100% infill, the tolerances for your hot end and your travel go way tighter, way, way tighter. And anything in the polymer that happens could create an accident at the hot end and knock the tower right off. And we saw that trying Purge towers and Prime towers with the tool changer. It just didn't work because the tolerance is because it's 100% dense, 100% infill. It's a solid block, and it's so easy for the plastic to get like a little tiny lip right where the end is, and then the hot end bumps into that, and it knocks it right off the plate. And then from then on, you've got extrusions happening everywhere, wherever you prime. So prime blocks and prime towers, they are no solution. There is another solution that Simplify 3D does called a kind of a wipe skin, where it puts a shell around the entire object so that as the hot end, if it's dripping or oozing, it's kind of an ooze shield, it hits that before it gets to your object. And then after it finishes, it draws the line, that outline of the object. That worked pretty well. I've used that quite a bit, but boy, it's intrusive. I mean, it adds a lot more print time, and some objects just do not lend themselves to being completely encased in a shield of plastic. So the optimal solution I've found has always been to have an external area away from the print area to purge, and you only have to purge a little bit, and then a physical wipe, an actual physical wipe, and then you go print. That's been what I found to be optimal.
Yeah, that's totally optimal. It's more difficult for the manufacturer, which is why you see printers coming out without it. It's easier for them to say, just like in the early days, it was easier for them to say, oh, print with a raft, just to sort of make up for the fact that their bed wasn't level and couldn't be leveled. You know, it's like, oh, well, just use a purge block. Yeah, that's fine. But no, give us a engineered solution in the hardware of the printer that obviates the need for a purge block. That's what you need to look for.
Right, I agree.
So I've embarked on another interesting project. Just this last weekend, I took delivery of a Ford Transit cargo van that I'm converting to a camper. And it's an interesting project from the 3D scanning, 3D printing point of view, because there's a lot of little parts that you can either buy them from somebody or you can make them yourself. But in this case, I started out with this completely empty van. And I need to make, plans. I need to design what I'm going to build inside of this shell. And I went in there with my measuring tape and my notepad and started taking measurements. And I noticed very quickly that virtually nothing in that van is straight, right? It's a vehicle, so most of the surfaces in it are curved, except for the floor is flat, but everything else is pretty much curved in some respect. And I thought, well, this is going to be a pain in the ass to measure. And then it occurred to me, wait a minute, I have sitting on my bench, a couple feet away in the shop, I have a LiDAR scanner. So why not? So I brought my LiDAR scanner out, set it up, and started taking some scans, and then brought them back in and put them in a program called Cloud Compare and started looking at them. Now, the thing to remember is that a LiDAR scanner is just producing a point cloud, right? So what do you do with that? Well, it gives you a really cool 3D picture of what you're looking at. But then I discovered that you can actually take that point cloud and I can cut a slice out of it in any axis I want. So, for instance, if I want to know the exact shape of the van between, two of the ribs in the middle of it, 3 feet, forward of the rear wheels, I can figure out exactly where that slice is, slice it out of the point cloud, and then I can export that slice from the point cloud, and this is just basically, so now I have an outline, but it's not a CAD drawing, but it is an exactly to scale drawing of the points of that section of the van. So I can export it from Cloud Compare just as a JPEG or a raster graphic. and import it into my CAD software. In this case, I'm using TurboCAD because it's really easy to do 2D stuff in. And there's a scale bar on the JPEG that I can use to scale it to real world size. And then I can take all my measurements. I can trace. I can take any measurement off it that I want. I could derive, if I wanted to, CNC cut something that was going to fit into the van. I can derive the exact cutting path from that slice of the point cloud. So. Pretty powerful tool. If I didn't have a LiDAR scanner that I built myself at home, would I go out and buy one? Well, no, because it would cost more than the van. But if you've got a inexpensive homemade LiDAR scanner at home, this is a great application for it.
Okay, so I want to ask you a question. So why not take the scan, right, and turn it into a mesh, clean it up, you get it to scale, right? Bring that into, say, Blender, as an example, something that you can do Boolean remove from other mesh objects. Create a mesh object that's, say, rectangular in shape. And the intent here is to make a part that will fit exactly to the shape of the interior metal of the van that stands off away and allows you to make it a squared off surface. So you make that out of nylon, and that can somehow bond on the interior of the van metal. And then onto that, you would put a flat surface, like maybe a sheet of plywood or some other structural material. And so that now the interior of your van is squared off, and it makes sense for human habitation, creating a bed and cabinets and things like that. Why not do that?
Yeah, you could. That would be a whole lot of work, and more work than you really need. You don't need 3D scanning to make spacers. In fact, it's designed. There are parts of it that you can bolt. It's designed to have a liner in it, so you can put in plywood. The cargo vans, it actually came with these plastic liner panels that are sort of designed to be indestructible. But I took them out because they're not the aesthetic that I want. But yeah, you can make flat panels to put on the wall. In fact, I'm going to, but I got to insulate behind the panels first, so that you're not living in a tin can.
So it must be a pretty long van because you're a tall guy.
Well, that was what sold me on the Ford Transit. It's a high roof. The standing room in the high roof with everything stripped down before I put any insulation or any flooring or anything in it. The standing room is 6'9".
Wow.
Which is tall enough even for me.
Cool. Well, I imagine we'll hear more about the van in the future.
You bet.
Oh boy, Whitney, another show written to the hard drive, waiting for encoding, uploading, and commitment on our feed to all of our very supportive listeners. Thank you all for your support out there on Patreon. Thank you for your positive reviews wherever reviews can be made. And hey, thanks for listening. We do it for you. We do it for fun. No advertisements. We don't even like to advertise ourselves. We do this because we just love talking about 3D printing. And we figured, let's just turn the mics on and see if it's worth listening to. We hope it is. We think it is. We hope it is. And we hope you enjoy it. I got a thing of the week.
And it's a cool one.
Yeah, this one is called the Geodesic Dome Cat House. Now, this is for felines, not for human beings, so it's small.
Not that kind of cat house.
Yeah,
Okay.
now, I really got a kick out of this for a bunch of reasons. Besides the fact that I don't have a cat, but I love cats. I don't have a cat because my kids were allergic, but we used to have cats, and I like cats, and I also like dogs. Anyway, be that as it may, this is a great little cubby kind of hideaway for your feline pet. But the thing about this thing that I really got a kick out of is that they give you the parts and the geometry to make it any size. If you've ever made a geodesic dome, making the struts is a little complex. I shouldn't say a little complex. It's very complex. It's easy to make mistakes. I built a 30-foot diameter dome in my younger years with a bunch of friends of mine, and it was not an easy thing to do. It's very, very complicated. Now, what this maker, by the way, and the handle of the maker on Thingiverse is Abby575. You got the maker's name?
Otherwise known as Kazuhiko Hata. Kazuhiko does not tell us where they are from.
It's pretty sure bet that they're in Japan. Pretty probable. And I'm making that guess.
They do talk about a like a sort of a Japanese straw craft, folk craft a cat house that this is sort of based on, I guess. So it's probably a good guess, but who knows?
Actually, I'm making that guess because of the stuffed animal on the top of the dome. That's based on a cartoon character. Let's see, it's thing number 4817590, so the maker gives you the tiles, the triangles, so it's the struts and the triangles are all one part, and they're all the correct geometry, and they in the post they show you how to make sure that you don't make the kind of mistakes that me and my buddies made years ago. And what's really cool is you can easily scale up the size of this dome. You can make it for a dog, or you can scale it way down and make it for a hamster. This is really cool. I think it's a great thing, very, very useful. And I got to admit, I'm really tempted to make it, even though I don't have a cat in our house. And it would be a bit too big for our dog. It would be good for outside for a dog, but not inside. It would take up a lot of room. But it would be a fun project, yes. Definitely a lot of fun.
Yeah, it's very, very clever. All of the different panels are connected together using zip ties on the inside, which makes it very quick and easy to put together, and also would make it quite, it would be sort of flexible, but quite resilient, very tough.
Yeah.
And if you are a fan of cats, I'm violently allergic to cats as well. But I can't have them, but I do think they're cute. And there's an awful lot of cute cat pictures in this post too.
Yeah, there are. They're very cute. If you've got a tip, a question, or even more, a candidate thing of the week, what are you waiting for? Send us an email.
Send it to info@3dprintingtoday.com. That's THREE, the letter D, printingtoday.com.
We also invite you to join our online community. If you go to Google and Google 3D printing tips and tricks, it's an open forum, but you do have to join. And to join, you have to give an email because it's a Google group. On the other hand, if you don't want to give an email for some special reason, we also have a completely open group on Facebook. If you search Facebook, just search 3D Printing Today, number 3 in 3D, in 3 separate words. You don't have to join anything. It's open, and you can post there questions and comments.
Right, because obviously you don't have to give an email to Facebook or anything to get on there.
They've already got all your information, so they don't ask. They already have it. Let's see.
They don't have to.
They don't have to ask. That's right. Let's see. We do have a show next week. Show number 383.
We start out with crowdfunding fails.
And then we're going to be getting a clean bottom on prints with the belt. How to do that. It's a little trick to it. And I think that's it.
Great. Thanks for listening.